Hi students, today we will discuss a comparison between compound interest and simple interest. In my earlier videos, you have learned what is simple interest and their problems, and in other video you learned what is compound interest and their mathematical problems. Students, these two chapters are very much important for your studies. For competitive exam in banks, WBCS, Reserve Bank of India, Railway Recruitment Board, these sorts of problems set there. Students, let us find the distinction between compound interest and simple interest. For the sake of simplicity, let the principal be 100, rate of interest 10% per annum, and time period is 3 years. Here, interest is compounded annually or yearly. Let us consider the compound interest in this table. In the first year, let principal be 100. So, what will be the interest for the year? 10% per annum, that is rupees 10. So, amount at the end of first year, it will be 110. Now, what would be the principal of the second year? In case of compound interest, the amount of the first year would be the principal of the second year, that is 110. Now let us calculate 10% of 110, that is 110 into 10%, that is rupees 11. So interest for the second year will be 11. Now what would be the amount? Principal plus interest, that is 121. It is the amount for the second year. Now what would be the principal for the third year? In case of compound interest calculation, it will be 121. That is the amount of the second year will be the principal of the third year. Now let us calculate 121 into 10%, that is 121 into 10 by 100, that is 12.10. So interest will be 12.10. So amount will be 133.10. And here see what would be the interest. It will be 33.10. From this table, it is clear that if 100 is invested at the rate of 10% per annum, where interest compounded yearly, so amount will be 133.10 after 3 years. Now let us consider what would be the simple interest after 3 years for the same amount at the same rate and for the same period. Here for the first year, principal invested is 100. What would be the interest? That is rupees 10. So amount will be 110. Again, in the second year, the principal will remain same. Why? This is the basic difference between simple interest and compound interest. In simple interest, interest is paid at the same rate for the 3 years uniformly. No change will be there. So here principal will be 100 and it will be at this end of second year. So amount will be 120. Again, at the beginning of third year, the principal will remain same because the amount is invested for 3 years. So principal never be changed and interest will be at the same rate, that is 10. For rupees 100, 10% of 100 means rupees 10. So interest will remain same and the amount will be 130. So students, here see, the amount obtained in simple interest is 130, whereas the same amount when invested in compound interest system, here A equal to 133.10. So from the table it is clear, whenever the two periods are same, that is it is invested for 1 year and it is invested for 1 year and interest compounded yearly, the amount will be same. This is the exception when simple interest and compound interest are equal. Now here see, whenever it is invested for 2 years, the interest is more. Here interest is 11 and here interest is 10. Here in every case interest is same and in every case interest is changed. This is the basic difference between simple interest system and compound interest system. So you see, whenever time is more than 1 year, that is compound interest is always more than 33.30 is greater than 30. In banks, simple interest is given in savings deposits. If the customer deposits in fixed deposits, bank allows compound interest at quarterly basis. I think from the table it is clear what is the basic difference between compound interest and simple interest. Students, let us consider the mathematical problem. Simple interest and compound interest of a certain sum is rupees 800 and rupees 820 respectively for the period of 2 years. Given that interest is compounded annually, find the sum, that is principal and rate of interest per annum. Students, here see, simple interest equal to rupees 800, it is given. Compound interest is given rupees 820. Here time equal to n equal to 2 years. Let the principal equal to P and the rate equal to R% per annum and principal is rupees P. So we can calculate SI equal to P into R into, here T is 2 by 100. This implies that 800 equal to here 50 PR by 50. Therefore PR equal to 40,000. Now what is CI? The formula of CI is A minus P. where A is the amount, where A equal to P into 1 plus R by 100 whole to the power here. Here N equal to 2. Therefore, Ci equal to P into 1 plus R by 100 whole to the power 2 minus P. That is, we take common P, 1 plus R by 100 whole square minus 1. That is P into 1 plus 2 into 1 into R by 100 plus R square by 10,000 minus 1. 1 cancelled. That is equal to 2 PR by 100 plus PR into R by 10,000. That is, it is PR square, but I have written PR into R because the value of PR is 40,000. So we can write 2 into 40,000 by 100 plus PR means 40,000 by 10,000 into R, this R, that is, it is 4, and here is equal to 2 into 400, that is 800 plus 4R. Here CI is rupees 820. Therefore, we can write 820 equal to 800 plus 4R. This implies that 4R equal to 820 minus 800, that is 20. Hence, R equal to 20 by 4 equal to 5. Students, what do we get? PR equal to 40,000 and R equal to 5. That is, R equal to 5% per annum. That is rate of interest per annum. Hence, P equal to 40,000 by 5. That is 8,000. Therefore, principal is rupees 8,000 and rate equal to 5% per annum. Here C, the problem, prove that compound interest is more than simple interest on any principal for 2 years, where interest is compounded annually. Students, here only one thing is given, that is time. Time equal to N equal to 2 years. Let principal be P and rate of interest is not given. Rate of interest equal to R% per annum. So, what is the simple interest for 2 years? Let SI the simple interest. It is P into R into T by 100, we know. So, it will be P into R into T means 2 years by 100. Now, let us calculate what is CI. We know CI is A minus P, where A equal to P into 1 plus R by 100 whole to the power 2. Here n is 2. Therefore, Ci equal to P into 1 plus R by 100 whole to the power 2 minus P. Here we take P common, 1 plus R by 100 whole square minus 1, that is P into 1 plus 2 R by 100 plus R square by 10,000 minus 1. Here 1 minus 1 cancelled, that is equal to 2 PR by 100 plus PR square by 10,000. Students, here see what is SI? SI equal to 2 PR by 100. So this is SI plus PR square by 10,000. Therefore, we can write Ci equal to SI plus PR square by 10,000. PR square by 10,000 is greater than 0 because principal is always positive and R square is positive. Here 10,000. Therefore, we can write Ci is greater than Si. Since PR square by 10,000 always greater than 0, therefore we can write compound interest greater than simple interest. Let us consider the problem. If the compound interest on a certain sum at 10% per annum for 3 years is rupees 1986, where interest is compounded annually, find the simple interest of the same sum at the same rate of interest and for the same time period. Students, what is given? Rate of interest equal to 10% per annum, T equal to 3 years. Let principal equal to P. Here given compound interest is rupees 1986, that is Ci equal to rupees 1986, but we know Ci equal to A minus P, that is P into 1 plus rate of interest, that is 10 by 100 whole to the power 3 minus P, that is P into 1 plus 1 by 10 whole to the power 3 minus P, that is P into 11 by 10 whole to the power 3 minus P. Here we can write P into 1331 by 1000 minus 1 equals to P into 331 by 1000. This implies that here what is the value of Ci? 1986 equal to P into 331 by 1000. Therefore, P equal to 1986 into 1000 by 331. Here we cancel it by 6. This is 6000. Therefore, principal equal to rupees 6,000. Therefore, principal is rupees 6,000. Now we have to calculate the simple interest of the same sum. So SI equal to, here 6,000 is the principal, rate of interest is 10 and period is 3, that is 1800. So the simple interest equal to rupees 1,800. Students, let us consider another problem. The current price of a machine is rupees 10,000. The rate of depreciation is 10% per annum. If the depreciation is made yearly, then what would be the value of the machine after 3 years? Find also the amount of depreciation. In case of depreciation, the formula is A equal to P into 1 minus R by 100 whole to the power n, and amount of depreciation equal to P minus A, because after 3 years amount of the machine will be less, so P will be higher. So amount of depreciation will be P minus A. Here P is rupees 10,000. Rate is 10% per annum. Rate of depreciation is 10% per annum, and N is 3 years. Therefore, A equal to rupees 10,000 into 1 minus 10 by 100 whole to the power 3, that is rupees 10,000 into 10 minus 1 by 10 whole to the power 3, that is rupees 10,000 into 9 into 9 into 9 in by 10 into 10 into 10. Here 3 zeros are cancelled, that is rupees 10 into 81 into 9, that is rupees 0. So the value of the machine will be rupees 7,290 after 3 years. Therefore, depreciation will be P, that is 10,000 minus rupees 7,290, that is rupees 2,710 only. So amount of depreciation will be 2,710 and the value of the machine will be rupees 7,290. Students, let us consider the problem. The population of a town increases at the rate of 5% every year. If the present population of the town is 1,60,000, find the population of the town after 3 years. Find also the ratio of population growth for the first and second year. Students, here is 2 questions. Find the total population of the town after 3 years and rate of growth of the population for the first and second year. Here see population at the beginning of the first year equal to 1,60,000. Here 5% of 1,60,000 equal to 8,000. So the population growth is 8,000 for the first year. Therefore, population of the second year equal to 168,000. Population of the beginning of the second year, because at the end of first year population will be 1,68,000 at the end of the first year, that is beginning of the second year will be 1,68,000. Again 5% growth, that is 5% of 1,68,000 equals to 168,000 into 5 by 100, that is 0,084. So here growth for the second year 8,400, that is total population at the end of second year will be 1,76,400, and population growth for the second year is 8,400. Here see population at the beginning of the third year equal to 1,76,400. Now it is 5% added again, 5% of equals to 8,820. Therefore, population after 3 years equals to 1,85,220. Here see the total population after 3 years will be 1,85,220, and ratio of population growth for the first year and second year equal to, here population growth for the first year is 8,000 and for the second year is 8,400. That is 20:21. Students, here the population growth for second year and first year is required. For this, we calculate the growth of the first year, that is 8,000. Once again, we calculate the growth of the second year, that is 8,400. And finally, we get population of the town for after 3 years, that is 1,85,220, and the ratio of the population growth of the town is 20:21. Students, the problems discussed in this chapter is comparatively hard. Therefore, I suggest you to solve all the problems carefully. Students, if you like my videos, please give your like and share my videos to your friends. Thank you for watching my video.
Subscribe to our channel and press the bell icon to get all the notifications. You can also like the video and share the video in your groups.